All right, so solving linear systems elimination method. So when you're solving linear systems by elimination, these are the 6 steps that you follow. The 6 steps are already listed on your paper if you look at your paper. So step 1 tells us to arrange the equations with like terms in columns, okay? So by arranging the equations, we want to make sure that we are in standard form. So that's your AX plus BY equals C, okay? So we arrange, make sure we're where we need to be. Then we're going to find a least common multiple, okay? Least common multiple is what is the smallest number you can multiply by in order to eliminate one of the others, okay? Then you're going to add the equations together. And the goal is while you're eliminating that you're going to, when you add together, one should eliminate, okay? For your least common multiple, it may need to be negative. Okay. So it may need to be negative. And then we're going to solve the remaining variables. And then we go back and substitute. And then we check our solution. Okay. So these are a little more steps, but totally doable. So the best way to see this through is just to do it. So we're going to start here with example 1. So for example 1, we have 2x minus 5y equals 11. And we have 3x minus 2y equals negative 12. So step 1 is to make sure that you're in AX plus BY plus C form. Am I in standard form? Yes. AX plus BY equals C, AX plus BY equals C. Do we see that? All right. So then step 2 is to find your least common multiple, okay? So to find your least common multiple, you have to decide which variable do you want to eliminate. So for number 2, you have to decide, are you going after X or are you going after Y? It honestly does not matter. I'm going to get rid of X because it has smaller numbers. So for X, that's not how you make an L. Let's try that again. For X, the least common multiple between 2 and 3. What is the smallest number that 2 and 3 both divide into evenly? 6. The least common multiple equals 6, right? Okay. So I'm going to multiply. I need to transform these so that each one of these equals 6. So what would I have to multiply the first equation by in order for it to equal 6? 3. I would have to multiply the first equation by 3. And what I do to one side, I have to do to the other. And what would I have to multiply the second equation by in order for it to equal 6? 2. And what I do to one side, I have to do to the other. Now the goal is for them to eliminate. So in order for them to eliminate, one of these numbers have to be negative. And since this isn't already negative, I'm gonna have to make one of them negative. It doesn't matter which one you make negative. So now you perform the operation. So I distribute 3, and that leaves me with 6x minus 15y equals 33. I distribute, and that leaves me with negative 6x plus 4y equals 24. So the purpose of step 2 is to set yourself up for elimination when you add them in step 3. So in step 3, I'm going to add them together. When I add these two together, what happens to my x's? What's 6 plus negative 6? 0, right? They eliminate. Hence why it's called elimination. What's negative 15 plus 4? Negative 11. And what's 33 plus 24? Okay, and the last thing you want to do is get y by itself. So what do I need to do to get y by itself? Divide. Step 4. Solve the remaining variable. So we end up with y equals negative 57 over 11. Fractions are our friends. They happen. So now we have y. That is only half of our solution, not our full solution. So step 5 tells you you're going to take what you got here and you're going to plug into either one of these equations to get your x value. It doesn't matter which one, whichever one makes your heart happy is what you're going to plug it into. So you can choose the first one. So if we use 2x minus 5y equals 11, we're going to substitute in for y. So we have 2x minus 5, but we know what the value of y is, which is negative 57 over 11 equals 11. Does anyone know the trick of getting rid of a fraction? If you only have one fraction in a problem, does anyone know how to get rid of it? No? All right, the trick is you multiply all terms by that one fraction. So notice how I have just an 11 in the denominator. If I multiply everything times 11, I eliminate that 11. So I go from having a fraction to not having a fraction. And that gives me 22x minus 5 times negative 57 equals 121. Now I don't want to, let's see. I'm gonna do it in brain. I'm gonna try. I was gonna pull out a calculator. What is 5 times 57? Well, a negative times a negative is a positive. 5 times 57, 5 times 7 is 35. Regroup the 3. 5 times 5 is 25, and 25 plus 3 is 28. Sorry, it's going sideways. I like seriously missize these boxes, guys. Okay, so then now you're on to isolating. What do I need to do to get x by itself? Subtract. Good job. That gives me 22x equals 4, 6, negative 164. You can verify it in the calculator. If you want to do 121 minus 285 for me. I think I did it right. And then we divide by 22. So x equals that. But these can be divided by 2, right? So that gives me negative 82 over 11. So I have my x, I have my y. So step 6 is to write it as a solution. What is my solution? My solution for step 6 is negative 82 over 11, comma, negative 57 over 11. Okay, the thing is, if you were to use a graphing calculator or a calculator in order to solve this, would it give you the exact value? No, it would give you a rounded decimal, right? And so you'd only get partial credit for giving me the approximate decimal. But if you're looking for the exact value, then that is typically written as a reduced fraction. Okay, we're gonna do 2 more, see how it goes. Nope. All right. All right, so then we're good to go. So step 3 is to add them together. What happens when I add the y's? They cancel out, they eliminate, right? And I'm left with 12 and negative 6x, which is 6x, equals negative 8 and negative 4, which is negative 12. Step 4 is to solve for the variable. What do I need to do to solve for x? Divide. So I get x equals, what's negative 12 divided by 6? Negative 2. So I have my x. To find my y, I take this and I'm either going to plug it into this one or that one. Does it matter which one? No. I always choose the one with the smaller numbers. So I'm going to use 3x plus 4y equals 2. Where x is, I'm plugging in negative 2. So we have 3, but instead of x, it becomes negative 2 plus 4y equals 2. Do you see what we did there? We substituted in for x, right? And when it's 3 times negative 2, what are the steps I have to take to get y by itself? It's gonna be what? How do I move the 6 over? It's a negative 6, so I'm gonna have to make it a positive. So I add 6 to both sides. That gives me 4y equals 8. And now what do? Divide. Okay, remember, before you can divide or multiply, if there's addition or subtraction in front, you have to get rid of that. So y equals what? 2. So my solution is negative 2, 2. Okay, so if I'm not sure, then I always can plug it in and I can check and see, oh my gosh, it works. Okay. We're going to try one more. So for this one, I would encourage you to work ahead. So I would like for you to try, listen, look up if you get stuck, but I would encourage for you to give it a shot on your own. Okay. All right, so step 1, we're in order, we're good to go. Step 2, decide on a variable. I'm going to probably eliminate x. And the least common multiple for negative 2 and 10 is 10. Because 5, does 2 divide evenly into 5? Nope. So what do I need to do to negative 2 to turn it into 10? Multiply by 5. And what I do to one side of the equation, I have to do to the other. Do I have to do anything to the 10? No, it's already 10. So I'm going to distribute, transform my equation. So we have negative 10x minus 20y equals 10. And then we have 10x plus 20y equals negative 10. All right. Step 3 is to add them together. Uh-oh, what do you notice when I add them together? They all cancel out. They all are eliminated, right? When this happens, what that means is that it's infinite solutions. As everything eliminates, then the answer is infinite solutions. Okay, so with that in mind, everything eliminates, infinite solution. Note to self, if this had happened, if I had negative 10x and 10x minus 20y equals 10, plus 20y equal 10. If only the variables eliminate and your constants are still there, that means that you have no solution. Everything eliminates is infinite solutions. Only the variables eliminate means no solution. Do we see the difference between the two? All right, that concludes our notes.